Hi, I'm Alan. And so The Economist just reminded us yesterday that we are literally watching the world burn because of climate change, and that's a problem. The general plan for dealing with this is to take all the things that emit carbon, electrify them as much as we can, and then decarbonize the power grid. And so that implies that we're going to have to change the structure of the grid pretty substantially. So we have to make a lot more electricity, and we have to make it in different ways. So this is the model that the grid currently uses. It's called GTDR, so generation, transmission, distribution, and retail. And generally, power is made in power stations. It's transmitted over high voltage lines to substations, where it's stepped down and then distributed to consumers. Generation always has to equal load on the grid, second to second. Generation is stable, whereas consumption is variable. So if you are trying to run the grid, you can't control when people are flipping lights on and off, but you can control when your coal plant is generating. And a third design principle here is radial flow. So you have these very large producers that are where they are generating electricity in this very sort of centralized way and distributing it to tens of thousands of small consumers per generation node. And so if we are going to change this model to decarbonize the grid, one of those changes is that, firstly, generation is going to be variable. So it's going to come from wind and solar. Secondly, maybe we can add storage, so generation doesn't always have to equal load on a second-to-second basis. And maybe we can control when people use electricity in order to try to make generation and consumption and load match each other better. And a third design principle that we can change is that we can start questioning this idea of radial flow and start allowing power to flow in different ways along the grid. And so some of the devices that might do this are, for example, electric cars, solar panels, all these things that are distributed could be allowed to trade power between themselves, right? And so how are they going to get price signals in order to do that? Well, so the way price signals are currently generated on the grid is that so producers will bid generation capacity into the grid, and retailers will bid in the price at which they want to buy power, right? So the first design principle is that the ISO that runs the power market wants to minimize the cost of generation. So that's that first constraint there. So they want to minimize the sum of all the production times generation. Next, generation has to equal load. Next, power lines can't conduct more power than they're rating, than they're rated to conduct. And then lastly, you have generation constraints. So power plants can only produce a certain amount of power. That gives you a system of equations, and they solve that system of equations. How do they figure out where power is valuable on the grid and where it's inexpensive on the grid, right? Because having a power plant near where power is being consumed is more valuable than having a power plant far away from consumption where you might have transmission constraints. So what they do is they take they take all the marginal producer that is defining the cost of power going into that grid. They look at, for every individual production node, how does that production node change losses on the grid? So that's that loss factor, LF. Then they add in this congestion component. So that means if you look at for every branch, so every transmission line that is near its capacity constraint, how much does increasing power at this individual generation facility affect the overall cost of grid power due to that generation constraint, if that makes sense. And so from this, they calculate something called a locational marginal price. The problem with that is that these locational marginal prices, so here's an example of the Midwest sort of Great Lakes region. As you can see, these locational marginal prices will vary a lot, right? So some places power is really expensive, other places power is really cheap, and that's because of these transmission constraints and losses on the grid. And so the problem with this is that they only calculate this for the bulk power system, so generation and transmission. And so what we're looking at is the degree to which you can use some of these decentralized protocols in order to start calculating what's called a distributional locational marginal price. So can you start, rather than calculating run the ISO calculating the locational marginal prices at each of these generation and substation facilities, can you start doing these trades in a way where you can calculate locational marginal prices on a much more fine-grained level? And there are several different potential value propositions that you can add here, and that's what we're looking at here. So I'm excited to talk to any of you about ways in which you could actually implement some of these concepts. And also, if you want to learn more, there are a lot of great resources on this. One is the Simon Institute Real-Time Decision-Making Bootcamp. Are there questions, or is it just... Great. Cheers. Thanks so much.